Hi, Kristen. I decided to make a video because I think that videos are easier to get through than a PDF. So I made a video about this question that you asked, and I apologize in advance if you know most or all of this. Just based on your question, I wasn't sure what you knew, and so I wanted to make sure that I covered all the bases. So let's just look at that question that you asked. So Hank paid $229 every month for 30 years. He sold it for this amount. And what kind of annual interest rate would he need on an ordinary annuity to get the same kind of return? And so when somebody asks me a question like this, the first thing I try to do is just get a handle on what kind of return Hank actually got. And so let's just calculate how much money he himself invested. So he paid 229 bucks every month for 30 years for a total investment of 82 grand. So he sank 82 grand of his own money into this, and he sold it for 193 grand. So that's a profit of 101 grand, and he more than doubled his money on that profit. So not bad. So what kind of interest rate do you need to double your money, more than double your money? Well, here's the annuity formula, where S is the future value, R is the payment amount, N is the number of payments or deposits that you make, and I is the interest rate per period. So in this context of monthly stuff, I would be the interest rate per month. So the question asks about the annual interest rate. So rather than having the interest rate per period in the formula, it might be more helpful to have the annual interest rate. So just call it something else and have a formula with the annual interest rate there. So let's just take that formula and plug everything in. The future value of his investment was worth $193,000. He put in $229 per month, and there were 360 total payments. He paid monthly for 30 years. So here's just the equation that you would need to solve in order to find the annual interest rate. Now, I should have gone back and looked over the instructional materials for this, but I believe that what they should have said and what the book should have said is that once you reach an equation like this, this is very difficult to solve algebraically. Okay, what makes it difficult is that you have multiple r's, and one of them is being raised to a 360 power, and one of them is not. So that makes algebra here intractable and difficult. So if somebody asks you to solve for an interest rate in a problem dealing with this particular formula, then your only option is really just to fiddle with the numbers until you get something that looks right. So I just plugged different values in for R and tried to see what I got, and the R value that worked for me was a little more than 5%. So again, it's not terribly satisfying to just fiddle with the numbers like this, but in an equation like this, we simply don't have the tools to solve for little r. I mean, we can solve for big R, and we could also solve for big S, right? Big S is already solved for. So there are things you can solve for using normal algebra, but little r, the interest rate, is not one of them. If this were a simple interest problem or something, we could just solve for the interest rate. But this formula is complicated enough that we can't just do that. So this is what we have to do. But in the end, let's just notice, I mean, we discussed a second ago how he more than doubled his money. 5% is not huge. I mean, it's way more than you could get on a savings account, but this is not an unreasonable number for other kinds of investments. So you don't really need that big of an interest rate to more than double your money. So hopefully that helped.